In aromatic ring, if you replace a hydrogen with any of the halogen group, then it is said to be haloarenes. When two isomers, even though it looks same, okay, when we impose them on one another, it has become non-superimposable. Alkyl iodides are prepared by heating the alkyl chloride or a bromide in presence of dry acetone, and this reaction is said to be what? Finkelstein. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to start with the revision class for the Unit 10, Haloalkanes and Haloarenes. So this is a core unit in your second PUC. There are 4 core units will be there in the second PUC chemistry, especially in the organic chemistry. That is haloalkanes and haloarenes, aldehydes, ketones and carboxylic acid, alcohols, phenols and ether, and lastly with the amines. Okay. So these 4 chapters are very important for your CET as well as for your competitive exams. Okay. Let us see what is all about the haloalkanes and haloarenes. So in this unit, you will study the important methods of preparation, physical and chemical properties of organohalogen compound, okay, and alkyl halides of haloalkanes or aryl halides or the haloarenes on an organic compound which are obtained by just a replacement of one or more hydrogen atoms of aliphatic or aromatic hydrocarbon respectively with the halogen atom. So in this unit is study about the preparation, physical and chemical properties of both haloalkanes and haloarenes. Remember, in aliphatic chain, if you replace a hydrogen with any of the halogen atom, then we say it is haloalkane. Okay. In aromatic ring, if you replace a hydrogen with any of the halogen group, then it is said to be haloarenes. I can write the general formula. So you can see that the carbon is always having, okay, 4 valency. Correct? The valency of the carbon is 4, and we know that generally it is bonded with a hydrogen. If I replace any of the hydrogen with an halogen, it is called as what? Haloalkane. Okay, this is in the aliphatic chain. I can take any of the aromatic hydrocarbon example, and if you replace hydrogen and if you substitute any of the halogen, that is called as what? Haloarenes. Okay, so this is how the haloalkanes and haloarenes nomenclature which is also done, which is also important in this unit. Okay, let us see the weightage of this unit now. So from this unit, directly we can expect the 8 mark. There is a 1 mark question, that is a question number 11, and there is a 1 2 mark question, that is question number 22, and there is a definitely 1 5 mark question, that is a question number 42. Okay, so this is a question number 42 and it can be split into 3 plus 2, or you can expect 2 plus 2 plus 1, or it may be a 3 plus 1 plus 1 also. Next, let us discuss the 1 mark, 2 mark and a 3 mark question which has been raised from this unit. So the first question is, what are enantiomers? Okay, so the non-superimposable mirror images are called as what? Enantiomers. The stereoisomers which are related to one another and they are non-superimposable mirror images. Okay, so you can take the example of your palm only. Okay, these two are the mirror images of one another. When we superimposed, okay, they are non-superimposable. Okay, so this indicates that when two isomers, even though it looks same, okay, when we impose them on one another, it has become non-superimposable. So such isomers are said to be enantiomers. Okay, so what is chirality? An object which are non-superimposable mirror images are also said to be chirals. Okay, and sometimes it is called as what? Chiral center. Or you can consider the example of the carbon which has been substituted with different group. Okay, different group, then we say this carbon atom as chiral center or chirality. Okay, next, what are racemization? It is a process of converting enantiomers into racemic mixtures, which is known as what? Racemization. Expand DDT. DDT is nothing but dichlorodiphenyl trichloroethane. It is dichlorodiphenyl trichloroethane. Okay. Next, what is phosgene? Phosgene is an oxidized form of chloroform. So, how do you all write the chloroform? CHCl3. This is chloroform. So, when it is get oxidized, you will get a phosgene. You will get a phosgene. Okay. Next, Cl3Br plus AgF give rise to CH3F and AgBr. Name this reaction. So, the naming of this reaction, which is also very quite common in organic chemistry. So, you must know that which are the scientists who has discovered the reactions, especially in the named reaction. Okay. CH3Br plus AgF give rise to CH3F plus AgBr. Name the reaction. So, here most common in the haloalkanes and haloarenes is named reaction. Okay, you must know that which are the scientists who has discovered this reaction and how to name them. Okay, the name of this reaction is squats. Okay, which has been discovered by the squats only. What are freons? Freons are nothing but chlorofluorocarbons of the methane are known as what? Freons, and it is also known as what? Chlorofluorocarbons of ethane. Okay, ethane and methane. Name the organic compound which is formed when chlorobenzene is treated with sodium in dry ether. So, what they have given? They have given a chlorobenzene which has been treated with sodium in presence of dry ether. In presence of what? Dry ether. What is a product they are asking? So, usually we will get diphenyl where the sodium and the chlorine will combine to form a sodium chloride, and benzene ring they are connected to one another and forms what? Biphenyl ring. Which forms what? Biphenyl ring. Rx plus NaI in presence of dry acetone which gives R and I plus NaX. What is the name of this reaction? So, here you can see that just it is an inter-exchange of halogens which is happening. So, this was explained by Finkelstein. Hence, these reactions are known as what? Finkelstein reaction. Next, name the compound which is formed when 2-bromopropane is heated with alcoholic potash. So, it is nothing but what? 2-bromopropane. So, you can see that 2-bromopropane can be written as CH3CH3. It is 2-bromopropane. I can write on the second position to the propane where it is having bromine as the substrate group. So, when these are treated with alcoholic potash, what is a product that you are expecting? So, usually the potassium hydroxide will abstract a proton, okay, and this hydrogen will form a HBr, okay. As a result of this, it forms propene, CH3, CH double bond, CH2. It forms what? Propene. Next, we have 2 more questions. Explain the Finkelstein reaction with an example. As I said, in the Finkelstein reaction, we are just interexchanging the halogens. So, how to write the reaction? It is also very, very important. Alkyl iodides are prepared by heating the alkyl chloride or a bromide in presence of dry acetone, and this reaction is said to be what? Finkelstein. Remember, in the Finkelstein reaction, we can prepare only the iodo form of the alkane, okay, or you can say that alkyl iodides. Okay, the alkyl iodides are prepared by a Finkelstein reaction. How we can prepare? Only by using alkyl chloride or alkyl bromide. Okay, so I can explain with the general reaction, that is R and X, which reacts with sodium iodide forms a R and I plus NaX. I'll go with the CH3Cl plus NaI. So, in presence of dry acetone, what will happen? This alkyl group attached with the iodine, and the sodium chloride will be formed as a byproduct. This is a methyl iodide. What does it is? It is methyl iodides are formed. You can write the same reaction with the bromide also. Alkyl bromide react with the sodium iodide. In presence of dry ether, it forms a sodium methyl iodide plus NaBr. Okay. So, this is also another way to prepare the alkyl iodide. Okay. Next, explain the Schwartz reaction with an example. So, here the alkyl fluoride complexes, okay, alkyl fluoride complexes are prepared by this method. Hence, it is known as what? Schwartz reaction, by using only alkyl chloride and alkyl bromide in presence of metallic fluoride such as silver fluoride, mercury fluoride, cobalt fluoride and SbF3, and the reactions are said to be Schwartz reaction. And you can see that how do I written the general equation. R stands for the alkyl group and Br stands for the halogen. RBr, which is react with the AgF to give RF and AgBr. So, I will go with the specific example now. Methyl bromide I will take, which is reacted with silver fluoride, which forms what? Methyl fluoride plus AgBr. So, it is methyl fluorides are formed. Explain fatigue reaction with an equation. When aryl halides are heated with sodium in presence of dry ether and two aryl groups are joined together to form a biphenyl. As I taken the aryl halides, so I will go with a specific example directly. Okay, this is my halogen and this is my aryl group which is substituted with a chlorine. I will take the two molecule. If you treat with the sodium in presence of dry ether, okay, the sodium and chlorine will be combined to form a sodium chloride, and finally, the benzene rings are joined to one another to form what? Biphenyl. Next, explain Woods fatigue reaction with an equation. A mixture of alkyl halide and aryl halides are heated with the sodium in presence of dry ether as a medium. Alkyl benzenes are formed. So, what is a Woods fatigue reaction? In a Woods fatigue reaction, we are combining both Woods reaction and a fatigue reaction. So, in the Woods reaction, we have prepared the alkyl halide. But here in the Woods fatigue, we have learned that how to generate the fluorinated compound, correct? So, we are generating a Woods and a fatigue together as Woods fatigue, and where I am taking the aryl halide along with the alkyl halide and I am going to heat with the sodium in presence of dry ether. You will get a alkyl substituted group with the benzene ring, which we also call it as what? Alkyl benzene. Okay. So, here I have taken the bromobenzene react with the methyl bromide in presence of sodium by a dry ether medium, it forms toluene with a NaBr. So, this Na and Br will NaBr will be formed, okay, and this CS3 group which has been generated in this reaction will be substituted to the benzene and forms a alkyl benzene. Next, explain Friedel-Crafts acylation reaction with an equation. Remember, so when I say it is acylation, it is a process of adding a acyl group directly to the benzene ring. Okay, when we say it is alkylation, it is a process of adding an alkyl group directly to the benzene ring. Okay, so in acylation, you must know that this is the acyl group. So, RCOCl. Okay, so this is R is a variable group which we can substitute with any of the alkyl group, and this CO along with this alkyl groups are called as what? Acyl group. Okay. So, you can see that I have taken a chlorobenzene which has been treated with methyl acyl chloride, okay, in presence of anhydrous aluminum chloride. Remember, this CH3 C double bond O Cl combines with the AlCl3. This AlCl3 can easily abstract the chlorine and forms what? AlCl4 plus CH3 C double bond O plus. It generates the electrophile. This electrophiles, it can easily attach to the Vincent ring and forms what? Acetophenone. And the major product is 4-acetophenone because it attacks at para position. Okay, acyl groups are attacks at a para position. Next, explain Sandmeyer reaction with an equation. When a primary aromatic amine dissolved or suspended in a cold aqueous mineral acid treated with sodium nitrite and diazonium salts are formed. Mixing the solution of freshly prepared diazonium salts with a cuprous chloride or a cuprous bromide results in a replacement of a diazonium group by chlorine or halogen to form what? Sandmeyer reaction. You can see that here we have taken a primary amine. Primary aromatic amine it is, okay, it is aniline. When we treat with the very strong base, that is sodamide, in presence of halogen acid at a temperature around 273 to 278 Kelvin, it introduces a diazonium salts are formed. So you can see that this is a diazo group, that is the N2 group along with the halogen. Later you can treat with this diazonium halide with any of the cuprous chloride or with a bromide, where replacement of the halogen will take place and to give a product. Okay, this is how Sandmeyer reaction can also be explained. Next we have explain SN1 mechanism for the conversion of tertiary butyl bromide to tertiary butyl alcohol by SN1 mechanism. So remember, in the 3 mark, definitely in this unit, we can expect the SN1 mechanisms or SN2 mechanism. So in the SN1 mechanism, you must know that it is nothing but a nucleophilic substitution first order reaction it is. Okay. So how does a nucleophile can come and attacks for the tertiary butyl bromide? You must know with this common example. So here I have taken out the example of tertiary butyl bromide, which will be undergo SN1 mechanism and generate tertiary butyl carbocation, and bromide ions will be liberated out. Okay. So this is the first step. In the second step, a nucleophile from the medium, can attach this tertiary carbocation and forms what? Tertiary alcohol. Okay, and forms a tertiary alcohol and leaves this positive charge. Okay, so this is how the tertiary alcohols can be easily found from the tertiary butyl bromide, and it follows the first order kinetics. Hence, it is known as what? SN1 reaction mechanism. Okay, you can see that rate of the reactions are directly proportional to the concentration of alkyl halide. Hence, it follows the first order kinetics. Hence, it is a unimolecular first order substitution reaction. Next, explain SN2 mechanism for the conversion of methyl chloride to methyl chloride. So, most of the scientists are got confused to take a primary alkyl halide here and they'll write the tertiary alkyl halide for this SN2 mechanism. Remember, to explain SN2 mechanism, you have to take what? Primary alkyl halide. So, as I have explained that, I have taken as a primary alkyl halide. This is a carbon atom having a 3 hydrogen with a chlorine atom. So, when the nucleophile comes and attacks directly to this carbon atom, so since we know that nucleophiles are negatively charged and our halogen is also negatively charged. So, directly when they come and attacks, they repel with each other. Since they repel, we have to show that the nucleophiles are coming and attacks on the backside of the primary alkyl halide. When it comes and attacks, it forms an intermediate complex which is having both OH and Cl. Later on, this bond breaking will occur. As a result of this, we can get a methyl alcohol with the elimination of halogen. This is how, while writing the mechanism of SN2, most of you will show that OH are directly coming and attacking for the primary alkyl halide. No, it is wrong. You have to show from the back side. Why it is back side? Because the chlorine and halogen, they are both electronegative. They are repel with each other. Since they repel, they have to show in the back side. So, this is all about the reaction mechanism. Remember, SN1 and SN2 can be definitely asked for your exam. And this is a short question as I listed here in this haloalkanes and haloarenes. Hope you all understood with this unit. I'll come back with the next unit. Till that, take care and be safe. Thank you.